Hey everyone. To really understand how a protein works, we need to understand how it's made. So, in our brochure, which should be linked underneath this video, we talked about how DNA is made into mRNA and finally protein, really briefly. I'm going to discuss that a little bit more to make sure that you have an understanding of how antithrombin is really made. So firstly, a gene on chromosome 1, this is DNA here, is made into mRNA, and so this is your mRNA. The DNA is like an encyclopedia that tells the entire cell how to function, and the mRNA is like a little instruction manual which tells the cell how to make the protein. Here we can see that the SERPIC1 gene, which is turned into mRNA, is the instruction manual on how to make the antithrombin protein. The next step is for the mRNA to be converted into a protein, and this is done by another special protein known as the ribosome. The ribosome is like the worker of the cell. It reads this mRNA instruction manual and produces the antithrombin protein out of it. There are a few structures of protein that we need to understand. So proteins are made up of building blocks known as amino acids, and these are what the colored blocks are here. The sequence of these amino acids is known as the primary structure. What happens next is that these amino acids fold into localized structures known as the secondary structures of a protein. These include random coils, alpha helices, beta-pleated sheets, and many more. And finally, all of these structures combine to form the tertiary structure of a protein. And this is the complex 3D structure of the entire protein put together. And this is the structure of antithrombin here. It looks pretty complicated, doesn't it? So I hope that gave you a really basic understanding of what the structures of antithrombin are like and how it's made. Read more underneath to learn more detail about these different levels of structure in the antithrombin protein.